Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about IV flow rates. The process I'm going to use to do IV flow rates is called dimensional analysis. In the previous video on drug dosage calculations, we used dimensional analysis, but I introduced it first in a video called Metric System for the Sciences. So you might need to review that first if you have trouble understanding the process. There are different sizes of IV sets that could be used. In medicine, the two most common are what's called the standard macro drip set, which is 15 drops per milliliter, and the micro drip set, which is 16 drops per milliliter. So because there's 60 drops in a milliliter in the micro drip set, the drips are a lot smaller than in the macro drip set. But you could see other sizes as well, 10 drops per milliliter, 20 drops per milliliter, and so on. It's important to know the size of set that you'll be using. There's a number of different types of calculations that you may be asked to do with IV flow rates. So I think the best way to approach this is just look at a variety of examples. A very typical question would be like this one. It says you need to give a child 600 milliliters of fluid during a 24-hour period using a standard macro drip set. Again, standard is 15 drops per milliliter. And you're asked to calculate the flow rate in drops per minute. Just want to make a note that you might see GTT used. Instead of drops. It's the same thing. I'm going to stick to drops instead of GTT, but if you encounter GTT, just understand that that is the abbreviation or the symbol for drops. When you're doing IV flow rates, my recommendation is you always start with a volume divided by a time. So we know that we have to administer 600 milliliters of volume in 24 hours. We want drops per minute, so we need to change milliliters to drops. We will use the IV set size for that. We know that 1 milliliter is equivalent to 15 drops. So I will put milliliters in the denominator so that it will cancel. And then my volume is now in drops per 24 hours rather than milliliters per 24 hours. Now I don't want per hour, I want per minute. So I'm going to use dimensional analysis to change from hours to minutes. And what I do is I put hours in the numerator and minutes in the denominator. These have to be equivalent, so I know that 1 hour is 60 minutes. That allows me to cancel hours, and notice that my unit that will be left is drops per minute. Now we do the calculation. We're going to multiply 600 times 15, and we're going to divide by 24, and we're going to divide by 60. So you divide by any number in the denominator, and you multiply by any number in the numerator. When you do the calculation, you should get 6.25 drops per minute. That would be the drip rate. Once you obtain an answer, you might be asked to determine how many seconds for one drop. So for example, if you wanted to check whether the flow rate is correct, you might be asked to figure out how many seconds for one drop so that you can do a check. If you're asked a question like that, I think the best way to handle it is with proportion. And the way I'm going to set it up is 6.25 drops instead of a minute, I'm going to go 60 seconds. That ratio should equal the ratio of 1 drop per X seconds. So if you're asked to something like that, I would set it up as a proportion. Now we can cross multiply, so 6.25 times x is equal to 60. Divide both sides by 6.25, and you get 9.6 seconds, which is approximately 1 drop in 10 seconds. So if you're asked to check with something like that, that's probably the best way to go about it. Let's take a look at some other types of questions you might be asked. Our next example says you are using a macro drip set, which is 15 drops per milliliter, on a patient, and you observe 30 drips per minute. How many milliliters per minute is this? Students often have difficulty knowing what to start with, so my recommendation is you always start with a volume that you know and a time that you know. So we know a volume of 30 drips per minute. We're not going to start with our IV set. We're going to start with 30 drops in 1 minute. We want milliliters per minute. We've got the time factor correct, but we need to change drops to milliliters. That's where we use our IV size, which is 15 drops in 1 milliliter. Drops is in the numerator here, so I have to put it in the denominator so that it cancels. Now I do my calculation. 30 divided by 15 will be 2 milliliters per minute. Let's try some more. Our next example says you are using a standard macro drip set and you observe 40 drips per minute. How many milliliters will be delivered in 2 hours? So remember that when you're using a macro drip set, that's 15 drops per milliliter. That's the size. But we never start with our IV set size. We always start with a volume per time. We know we have 40 drips per minute. So I have 40 drops in 1 minute. My next step is to change my volume to milliliters. So I use the set size for that. And I know that 1 milliliter is equivalent to 15 drops. Drops will cancel, and that gives me the volume in milliliters per minute. I'm finding how many milliliters in 2 hours. So let's find out how many milliliters per hour. So I'm going to change my time factor from minutes. Since it's in the denominator here, I need to put it in the numerator and replace it with hours. These two things have to be equivalent, so I know that 1 hour is 60 minutes. So the minutes will cancel, and that gives me a volume per hour. And I get 160 milliliters per hour. In order to find out how much in 2 hours, you can just multiply by 2, but I'm going to set it up as rate times time. 160 milliliters in 1 hour. I'm going to take that rate and multiply by 2 hours. Hours cancel, and we get 320 milliliters. You could also use proportion for calculating that. If you know how much in 1 hour, you could figure out how much in another time. Let's try a couple more examples. A similar question to the last example says determine how many milliliters of fluid are delivered in 15 minutes if the observed drip rate is 2 drops per second and the IV set is 20 drops per milliliter. So again, I always start with a volume that I know in a time factor I know, which means I start here. So 2 drops in 1 second. Now I know that my IV set is 20 drops per milliliter. So I can change drops to milliliters by taking 1 milliliter equivalent to 20 drops. So drops will cancel, and that gives me milliliters per second. Let's change that to milliliters per minute. So I'm going to put seconds here and minutes here. These have to be equivalent. So 1 minute is 60 seconds. So now seconds will cancel, and that gives me the drip rate in milliliters per minute. So I take 2 times 60, 120, divide by 20, gives me 6 milliliters per minute. Then I want to know what amount of fluid is delivered in 15 minutes. Again, two ways I can do that. I can express the rate and multiply by the time. Minutes will cancel, and 6 times 15 gives me 90 milliliters. Or you can use a proportion. 6 milliliters in 1 minute equals X milliliters in 15 minutes. It's up to you what you prefer. Let's take a look at one last example, and in this example we're going to be adding medication to the fluid. Our last example says a patient needs 30 milligrams of a medication to be infused over 6 hours. The concentration of the drug in the vial is 15 milligrams per milliliter. The IV bag into which the drug is going to be added is 400 milliliters. The infusion set that we're going to use is a standard macro drip set, so it's 15 drops per milliliter. And we're asked to find the drip rate, what drip rate is needed. And when we're asked for drip rate, we're finding how many drops per minute. So our first step is to find out how many milliliters of drug needs to be added to the 400 milliliters of fluid. We know we need 30 milligrams of that medication. So what volume is needed? We use the concentration. So if we have 30 milligrams, we know that 1 milliliter contains 15 milligrams. So we know we need 2 milliliters of medication. We also need 400 milliliters of fluid. So together we're going to have 402 milliliters of both the drug and the fluid. So to find the drip rate, we start with that volume, 402 milliliters, over our time of 6 hours. We need to change milliliters to drops, so we use our set size, which is 1 milliliter is 15 drops. And we want drops per minute. So we've gone to drops, but it's still per hour. So we need to change hours to minutes. Because hours is in the denominator here, needs to be in the numerator here, and minutes needs to be in the denominator. These need to be equivalent. 1 hour is 60 minutes. So hours will cancel, and that will give me drops per minute. When I do the calculation, I get 16.75 drops per minute. So this is a little tougher because you have to find the volume of the medication, add it to the volume of fluid, and then set up your flow rate calculation with that total volume over the total time, and then adjust whatever units. These questions can be confusing because there's a variety of questions you can be asked. Just follow the guidelines of starting with a known volume over a known time, and then do whatever adjustments to units depending on what you're being asked.